Okay, so I want to walk through another example of rotating a conic section, or actually trying to find the axes so that we can eliminate the xy term and be able to sketch this particular conic section. Now, the xy term, that's the piece that really prevents us from completing the square. And so we went through a couple of examples already to know that. Oops, dismiss that. To know that to figure out the angle, we need to to solve the equation cotangent of 2 theta is equal to a minus c over b. And again, these are just coming from our coefficients. So here's our a, here's our c, which is a 1, and our b, which would be 10 root 3. So, 10 root 3, a little suspicious of a coefficient. I'm anticipating some multiple of 30 or 60 degrees. So let's see. So we get the cotangent equal to 11 minus 1. Oops, 11. Here's again. Ugh, my pen is not working. Let's try over here. 11 minus 1 over 10 root 3, which is 10 over 10 root 3, or 1 over root 3. So now we know that 2 theta would have a ratio of 1 to root 3. So 1 to root 3, 1 to root 3. So that's, remember, what 2 theta represents. That angle right there is 2 theta. And again, that's its cotangent ratio. So we know that 2 theta, snooze that guy, 2 theta is equal to 60 degrees. So we know that theta is equal to 30. So knowing that theta is equal to 30 degrees, now we can apply the translation or transformation formulas. And remember, those are x equals, it's based off of difference in sum of cosine. So x prime cosine of theta minus y prime sine of theta. So we know x is equal to x prime cosine of 30 degrees minus y prime sine of 30 degrees. And we know that for a 30-degree angle, 1, 2, root 3. So we know its cosine is root 3 to 2. So we get root 3 over 2 x prime minus the sine, which is 1/2 y prime. So that's what we're going to replace every x with. And then for the y value, remember, it's y equals x prime sine of theta plus y prime cosine of theta. And again, I see the sum and difference formulas in this particular equation. So that's what helps me remember, the cosine sine or sine cosine. And then so we do x prime sine of 30 degrees plus y prime cosine, of 30 degrees. And, again, really for the purpose of this video, I'm doing like these 2 steps. But if once you know it, in your work, you just, oh, okay, so sine of 30 is 1/2. So you could say, oh, that's a 1/2 x prime plus root 3 over 2 y prime. So there's what the y is going to get replaced with. Okay. So now we take our equation, 11x squared plus 10 root 3 x times y plus y squared minus 4 equals 0. And we're going to transform that. So, I said this in class, and just to remind you, be neat, right? Write small and try to stay as organized as possible. So we have, I'm going to erase this guy here, so I have a little bit more space. So we have 11x squared, so 11, but every x is going to be replaced with root 3 over 2 x prime minus 1/2 y prime. So we'll square that. There's your 11x squared plus 10 root 3. The x value, so root 3 over 2 x prime minus 1/2 y prime, times the y value, 1/2 x prime plus root 3 over 2 y prime, okay, plus y squared. So our y value again, so 1/2 x prime plus root 3 over 2 y prime squared minus 4 equals 0. Okay, now really, again, we're confident. We know we picked the right rotation. We know that the xy term isn't going to cancel. So I'm only going to keep track of our x prime squared terms in our y prime squared term. So again, thinking about where these are going to come from. So I know that if I square this out and take it times 11, I'll get 3 over 4 times the 11. So I'll get 33. Oops, there it is. Pen, there it is. So I'll get 33 fourths for that first coefficient for x prime squared. Again, squaring root 3 over 2 is 3/4 times 11. Okay. Then I'm also going to get, if I think about like an x squared prime term from there, as well as times that. So it's root 3 over 4, but then it's also times 10 root 3. So root 3 over 4 times 10 root 3 should be 30 fourths. So I'll write that down. Plus 30 fourths. And then there's one more place I'm going to get squareds, and that's coming over here. That's 1/4. So then I'll add that to, I think it should be a pen. There you go, plus 1/4. So I've got 33 plus 30 plus 1, that's 64 fourths or 16. That's a great number. And then let's, again, keep track of the y prime squareds. And I'm putting this y prime in parentheses squared, just again to distinguish that it's its own variable. We're in a new system. And let's keep track. So we come back to the beginning. So we have this 11, and we're squaring out negative 1/2. So that's positive 1/4 times 11. So we get 11 fourths for the first coefficient. And then we come over here. We've got this negative 1/2 there. We've got root 3. Oops. We got root 3 over 2 there, plus the 10 root 3. So that's going to be, again, the root 3's will cancel, which is nice. It's negative root 3 fourths times 10 root 3. So it's negative 30 fourths minus 30 fourths. And then our last one's going to come over here. Squaring out root 3 over 2 becomes positive 3/4. Okay. And then this has no other x's or y's, so we have that -4. I might as well just throw it over to the other side. So say it equals 4. Okay. Sorry, that should say equals 4. So let's keep track of what we have. We already said we've got 64 fourths, which is 16 for the x prime squareds. And then for the y prime squareds, equals 4. Let's see, we get 11 minus 18 is negative 19, plus 3 is negative 16. So we get negative 16 fourths, which is -4. And I divide by 4 to set this equal to 1. So I get 4 x prime squareds minus 1 y prime squared equals 1. And it's a characteristic shape of the hyperbola. Now, and we could have done our discriminant, b squared minus 4ac, and we could have also seen that would have been a hyperbola. Now, I'm going to just rewrite this one more step to make that 1, to make the 4 in the denominator, like a 1/4, and then minus y prime squared over 1 equals 1. And that way I can clearly see what a squared is and what b squared is. So I'm going to draw this hyperbola, and I like to draw then just the xy, the normal xy, not rotated. And then I will rotate that. Remember, we said it's 30 degrees, right? So we'll come up here with a 30-degree angle. Again, just an approximation. That'll be my x prime axis. And so then if I extend it into the negative x prime, and then my, oops, how silly of me. That's, I don't know if I said it right, but that should have been x-axis, y-axis. So there's our x prime, right? Because we're rotating 30 degrees. There's our 30-degree angle, and then rotate 30 degrees here as well. 30 degrees and 30 degrees. So now I can see in the x direction, I'm going to go the square root of 1/4, which is 1/2. And again, it's just a sketch. It's all kind of to my perspective here. So if this is 1, then half would be right there. If this is 1, let's say, then half is right there. So like I know it'll be opening if I make my box 1/2 that way and 1 this way. So remember, that sort of creates the asymptotes. So that if I connect the diagonals to be, to make them to make the asymptotes. So Wow, that got really big. And then we construct our hyperbola. Going in that branch, going in that branch, going in this branch, going in this branch. Okay, so there it is. And again, just sort of a sketch. And I'm most interested in the algebra, making sure that we can definitely eliminate that xy term. Um, you know, at one point we were worried about where are the focal points, what's the eccentricity. And although I, still think those are important, in this section I'm really focused more on the algebra than anything.